Hi students, as a part of Nanomaterials, today I am going to discuss the very important topic which is the classification of nanomaterials. Classification of nanomaterials. Right. Now before I discuss how the nanomaterials have been classified, first of all we have to discuss, that is, first and foremost we have to discuss what is the criteria which is the basis for the classification of nanomaterials. There are two criteria by which the nanomaterials can be classified. The one is based upon dimension, and the second one is based upon composition. So based upon dimension and based upon composition. So these are the two criteria by which the nanomaterials have been classified. Right. So before I explain or discuss the classification of nanomaterials based upon the dimension, first of all I would like to recap what are the nanomaterials. So what are the nanomaterials? I have clearly explained in the video in which I have explained about the nanomaterials interaction. So what are the nanomaterials? These are the materials having the structural components with at least one of the dimension less than 100 nanometers. With at least one of the dimension in 100 nanometers. That is the nanomaterial, or those are the nanomaterials. Now, in order to understand the classification of the nanomaterials based upon the dimension, you have to understand what is nanoscale, students. Nanoscale means 1 to 100 nanometers. 1 to 100 nanometers. 1 to 100 nanometers is the nanoscale. Now, based upon the definition of the nanomaterials and the nanoscale, now I am going to classify the nanomaterials based upon the dimension. Now, whatever the classification I am going to give about the nanomaterials based upon the dimension is the simplest version of the definitions. So, listen carefully. So, based upon the dimension, the nanomaterials have been classified into 4 types. The one is zero-dimensional nanomaterials. The second one is one-dimensional nanomaterials. And third one is two-dimensional nanomaterials. And the fourth one is three-dimensional nanomaterials. So first, a zero-dimensional nanomaterials. Listen carefully. So these are the nanomaterials in which all the 3 dimensions are in nanoscale. What is nanoscale? Already I have discussed. All the 3 dimensions are in nanoscale. Now coming to the examples of the zero nanomaterials, that is 0D dimensional nanomaterials, spheres and clusters comes under this category. Now, in the case of spheres and clusters, all the 3 dimensions are in nanoscales. So, spheres and the clusters. So, these are the spheres and these are the clusters. So, all the spheres and the clusters will be in the nanoscale in all the 3 dimensions. Those are called as zero-dimensional nanomaterials. So, coming to the second class of the nanomaterials based upon the dimension is one-dimensional nanomaterial. Now, what is one-dimensional nanomaterial? These are the nanomaterials in which two dimensions are in nanoscale and one dimension is above the nanoscale. 2 dimensions are in nanoscale and 1 dimension is above the nanoscale. So these are the simplified definitions of the 0 and 1D nanomaterial, students. Right. So examples of the one-dimensional nanomaterials are nanofibers, these are the nanofibers, nanorods, and nanowires, So these are the examples of one-dimensional nanomaterials. Now, what is the next class of nanomaterials based upon the dimensional, two-dimensional nanomaterials? Two-dimensional nanomaterials. Now, what are the two-dimensional nanomaterials? These are the nanomaterials in which one of the dimension is in nanoscale and two dimensions are above the nanoscale. One dimension is in nanoscale and two dimensions are above the nanoscale. And what is the nanoscale? 1 to 100 nanometers. Right. So examples of the two-dimensional nanomaterials are nanofilms and nanoplates. Nanofilms and nanoplates. So this is the example of the nanofilm or nanoplate. Now, what is the next class of nanomaterials based upon the dimension? Three-dimensional nanomaterials. So, three-dimensional nanomaterials. Now, what could be the three-dimensional nanomaterials? Three-dimensional nanomaterials are aggregates. These are aggregates. Aggregates means what? Combinations. These are the aggregates of either the zero-dimensional nanomaterials or one-dimensional nanomaterials or two-dimensional nanomaterials. That is combination of either the zero-dimensional nanomaterials or one-dimensional nanomaterials or two-dimensional nanometers or nothing but three-dimensional nanometers. And in the three-dimensional nanometers, all the three dimensions will be in the nanoscale only. An example of the three-dimensional nanometer is box-shaped graphene. So this is the box-shaped graphene. So box-shaped graphene is the three-dimensional nanomaterial. So this is the classification of the nanomaterials based upon the dimension, and it is a simplified version of classification of the nanomaterials based upon the dimension, students. I don't want to complicate the definitions. So I hope you got this classification based upon dimension. Now, what is the next criteria by which we can classify the nanomaterials? The next criteria by which we can classify the nanomaterials is composition, students. I'm going to write here again. So the next criteria, the second criteria by which we can classify the nanomaterials is composition. So based upon the composition, now let us see how the nanomaterials have been classified based upon the composition. Right. So based upon the composition, the nanomaterials have been classified into CMDC. Now, how to remember the CMDC? So, in order to remember the class of the nanomaterials based upon the composition, I have framed one sentence for you. That is, Chief Minister is reading the Deccan Chronicle. That is CMDC. Chief Minister is reading the Deccan Chronicle. C stands for carbon-based nanomaterials. M stands for metal-based nanomaterials. And D stands for dendrimers. And another C stands for composite nanomaterials. So based upon this sentence, Chief Minister reading the Deccan Chronicle, you can remember easily the class of the nanomaterials based upon the composition. If you like this sentence, please go with this sentence. or else you can frame your sentence on your own. Alright, so based upon the composition, it is amply clear that the nanomaterials have been classified into carbon-based nanomaterials, metal-based nanomaterials, dendrimers, and composite nanomaterials. So first, let us discuss about carbon-based nanomaterials, students. So carbon-based nanomaterials. The name itself implies, right? These are the nanomaterials which are rich in carbon content. These are the nanomaterials which are rich in carbon content. And the shape of these nanomaterials will be either the spherical or hollow shape, spherical or hollow, spherical or hollow shape, spherical or hollow, or they can be ellipsoid, or they can be in the form of a cylinder. Right? So carbon nanomaterials, which are carbon-based nanomaterials, which are rich in carbon content, will be in the shape of spherical or hollow, or eclipsed, or cylindrical. Right. Now, if the carbon nanomaterials are spherical or hollow or ellipsoid, if the shape of the carbon nanomaterials are either spherical or hollow or ellipsoid, then the carbon nanomaterials are fullerenes. If the shape of the carbon nanomaterials is cylindrical, then the carbon nanomaterials are carbon nanotubes. And these carbon nanomaterials, which are the fullerenes or carbon nanotubes, are lighter and very strong when compared to the steel as well. These carbon nanotubes are 4 times stronger than the steel. These are very lighter. And what is the importance of fullerenes and these carbon nanotubes, I am going to discuss in the upcoming videos, which are going to be made on the nanomaterials. So just I am giving the class of or classification of the nanomaterials based upon the composition. Now, based upon the composition, what is the next class of the nanomaterials? The next class of nanomaterials based upon the composition is metal-based nanomaterials. So, metal-based nanomaterials, examples are quantum dots. Quantum dots comes under this category. Quantum dots. What are quantum dots? Quantum dots are nothing but tiny semiconducting crystals. Quantum dots are tiny semiconducting crystals which contains n number of atoms in it. And while explaining the applications of the nanomaterials, definitely I will explain what are the quantum dots and what exactly is the purpose of the quantum dots. Now I am not going to explain in detail about the quantum dots, because I am discussing only the classification of the nanomaterials based upon the composition. But do remember that quantum dots are a tiny semiconducting crystals. Now, other than the quantum dots, even nano gold comes under this category. Nano silver comes under this category. Nano silver. And one of the metal oxide, that is TiO2, titanium dioxide. Titanium dioxide comes under this category. Titanium dioxide. Now let us discuss something about the titanium dioxide. So titanium dioxide is mainly used or extensively used in PST, means paints, sunscreen and toothpaste. PST, paste. Just remember paste, PST, paste, PST. P stands for paints, S stands for sunscreen, and T stands for toothpaste. So this titanium dioxide nanomaterial, which belongs to the class of the metal nanomaterial, is useful for PST. What is PST? Already I have explained to you. Right. Now next, which are very important nanomaterials, dendrimers. So these are another class of nanomaterials based upon the composition. So dendrimers are considered as nanopolymers. Considered as nanopolymers, friends. These are nanopolymers. And the surface, these are the dendrimers. These are the dendrimers. And the surface of dendrimers contains n number of chain ends. So these are the chain ends. N number of chain ends. If you observe this, n number of chain ends. So since these nanopolymers, which are the dendrimers, comprise of n number of chain ends, these chain ends can be tailored and functionalized with a desired functional group at this particular chain ends. Whatever the functional group we want to place, we can place at the chain ends. We can place the chain ends. And this dendrimers, as it is comprised of n number of chain ends, it acts as a very good catalyst. And about this, definitely I will explain while explaining the application of nanomaterials in catalysis. And not only that, students, 3D dendrimers contains interior cavities. 3D dendrimers contains interior cavities. What are these? These are the cavities, students. These are the cavities. So since these are the cavities, whatever the substance we want to place, we can place in the cavity. Cavity is the hollow space. Nothing is there in that, right? So what we can do, we can place whatever the substance we want to place, desirable substance. So that is the reason, as this 3D dendrimers comprise of interior cavities. These interior cavities may be filled with a drug molecule, right? And may be filled with drug molecule, and the dendrimers containing drug molecule is administered into the body. Whenever the dendrimers containing drug molecule is administered into our body, so definitely it will go and act upon the desired active site only. Why? I will explain clearly while explaining the application of nanomaterials in medicine. Right. So this is about the dendrimers. Right. And what is the last class of the nanomaterials based upon composition? That is composite nanomaterials. But what is composite nanomaterial? The name itself implies composite means mixture. So composite nanomaterial contains the mixture of nanomaterials and bulk materials. For example, nano clay is added to bulk material. Then a composite is formed. Nano clay is the nano material, and when this nano clay, which is the nano material, is added to the bulk material, then the physical, chemical, and mechanical properties of the bulk material will improve. So, for improving the physical, chemical, and mechanical properties of the bulk material, nanomaterials are being added. So whenever the nanomaterials are being added to the bulk material, whatever the material which is going to be obtained is nothing but composite nanomaterial. And this composite nanomaterials will have the good physical, chemical, and mechanical properties when compared to the actual actual bulk material. I hope you understood this classification of the nanomaterial, students, right? So if you really like this video, please do comment on this. Thanks for watching.